Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to make a simple game from a first-person perspective in Unity. So I've started up a project, and the first part is to make the scene. And until you've laid out the scene, usually we do something called white boxing or gray boxing. And to do that, I'm going to create a few 3D objects to be placeholders for my scene. So I might put a plane down for a floor, and then use cubes for some walls. And let's say I want my walls to be about 2 units high, quarter of a unit wide, and I'll position them so that they are flat with the surface of the plane. I might scale my plane a little bit, and we'll make it 4 units by 4 units by, or multiple by 4. Yeah, it's a bit much. Let's do 2. I'm going to rename the primitives so that I know what they are. And after duplicating my walls, for example here, I can just kind of position them where I want them. And if you're wondering how do I know which axis to use for things like rotation, the rotation is around that axis. So in this case, the Y would be 90 degrees around the white axis. If I put 45, you'll see that it's 45 degrees, and this is a appears to be a right-hand coordinate system. So if I put, for example, 5 degrees, oh, maybe, no, actually left-hand coordinate system. So here's 0 degrees. If I were to rotate 45 degrees or just 5 degrees, it'll show me which direction it's rotating in. And I can see it's rotating in this direction. And if I were to hold my hand so that my thumb was pointing in the vertical Y direction, my fingers would be rotating around this direction. So that means this is a left-hand coordinate system. And why do I want to know that? Well, it makes it easier for me to know that which direction things will turn. So here, for example, if I turn 50, of course, if I turn 90, it doesn't really matter which coordinate system it is, but it's good to know that in order to speed your development. And all I'm doing here is I'm using the position numbers to kind of position things fairly precisely. And I actually want this to be -10. So we can see this is the Z direction, that's the Y direction, and this is the Y direction, and that's the X direction. The colors on this this indicator are reflected on the arrows in your movement controls. And of course, we can use W, E, and R to change the position, change the rotation, and change the scale with the grab handles if we wanted to. but we can also do it numerically. And for this type of thing, using the numerical controls probably is the fastest. So now I have 4 walls. And just to make it a little bit more interesting, maybe I will add a few more. So I'm just going to copy and paste a few more walls. And I'll just position them. And then we have a space to run around it. I'm going to save this scene and just going to call it scene 1. So there's our scene, and that's what we'll start with. All these wall sections and this floor, if we kept everything organized this way in the hierarchy, eventually it would get very confusing. So one of the things we can do is we can also create something called an empty. And of course you might wonder, why would we need an empty? Well, an empty can be used to take objects and set them as children so that we can then organize our hierarchy. One of the things you want to do with empties is it's good if all your objects, if the empty itself when is positioned at 0, as you can see here, before I didn't position it before, and when I go to 0, 0, my scene does not go really to where I want it to be. So let's undo this. And before we attach things to the empty, what I might do is position my empty at 0 so that it's located at the center. Then when I take all my objects and make them children of the empty, then it's positioned at 0, 0, 0, 0 rotation. That way, if for some reason this gets located somewhere where it needs to not be, I can just quickly return it to its correct position. The next thing we want to do is work with lights. So there are several different types of lights you can add. You have point lights, directional lights, spotlights, area lights. Our directional light that was added by default in the scene is right here. You can position a light anywhere you want in the scene. Its position doesn't really change. With a directional light, its position doesn't change the lighting. The rotation, however, you can see does change the lighting. And what we might do is have a directional light. We might add another one. And this one I might rotate in a slightly different angle. And you can change its intensity. So for example, here I've changed it to a fairly light intensity, and maybe I'll position them all in the same location so they're kind of up and out of my way. And so I've got a main light and a fill light. I'm going to rename them. And then I'm going to parent them underneath an empty. Just to make the lighting a little bit more interesting, to make sure I can see my 3D objects. Okay, I can even change the color of my lighting. And so if I wanted a little bit of a blue hue, perhaps you can see it would change how this looks. So we have a floor, we have walls, we have lights. The main camera shows where we are looking from, and you can see that when you select the camera, it shows you a little picture-in-picture thing here, which shows you what the scene looks like from the camera's perspective. That's also what you see from the game view. This is a little bright. And if we hit run, effectively it's just sitting there still because we don't have any code to actually control what we're looking at. So we can move in the scene view, that's really our working view, to manipulate objects. The game view really is just showing you what the camera sees. If you don't have a camera, game view is blank because you're missing a camera. There's nothing to view from. So the next thing we need is something to act as the player. And what I'm going to do is just use a capsule. So I'm going to add a 3D object and we'll create this capsule. I want it to be positioned on the floor, so my Y position will be 1. And what I've noticed is my scene is a little bit small. So I'm going to take my walls. Actually, I'm going to put my architecture all under another empty. So I've got my walls and my floor all under this one architecture, and I kind of want to scale it in the X and the Z. I think probably 4 units. A bit too much. Maybe 3. That'll probably do. Notice that when I go look from underneath, you can't see the plane from the underside. That's because the plane has normals, view normals that only project from one side. But that looks like that will do. I just went into 2D view. If you go into 2D view, you only see from one side. If you go into 3D view, then you see the whole thing. So, for this capsule, we're going to add a character controller, which means that we don't really need this collider since the character controller has its own. We can remove components by clicking on the gear icon, and we can add components by clicking on the add components. And what we want is a character controller. And so we'll add a character controller. And we'll want this camera to be located inside of this capsule. So probably to make things easier, I'm going to position my capsule at 0, X and 0, Y, and then I'm going to do the same thing with my main camera. And obviously this will be a little bit low if I left the camera here. So I'm going to raise it up to about where I think eye level might be. And I'm going to parent the camera to the capsule. So I don't want to have that named as capsule. That's just going to be player. And the next thing is just to we now need to script this so that when we hit play we can actually do something. So to make this move, let's move the player out of the way for a second, and let's just create a cube. And if I wanted this cube to move, I would need to write some code. So to add code to an object, we're going to add a component, and we're going to, in this case, a new script. And I'm going to call this script spin. And then open this spin script. And while we're looking at the components in this cube, you notice it has the transform, which is what controls its position, its rotation, its scale. That's the primary thing that we need to modify programmatically to make it do things. So we're going to create a variable at the class level. We're going to make it public. And if you are used to coding where we tend to encapsulate our variables and make them private, in Unity you're going to do it somewhat differently. You're going to make your variables public. And the reason you do that is so that we can get access to them, and we can actually change values in here. You notice that the default value I placed in shows up, but I can now change I'll be able to change what speed it rotates at by accessing this public variable. And the way I make myself feel better about it, I notice that the speed is capitalized, so I think of this as creating the property that gives me access to it. And within Unity, we are just making this public. Another way you can do that is you could actually make this private. If I made that variable private, you'll notice that it's no longer visible here, so then I wouldn't be able to change the speed within the designer. But what I could do instead is add an attribute. I could select the serialized field attribute in these square braces, and when I did that, I now have access to that variable. It will be accessible through the designer, but from a programmatic perspective, then my variable starts off as private. So there's a number of ways of doing it. And then, of course, I could start creating a property for it if I want to do it that way. So we'll leave it this way. And we're going to use this to set a speed. We have a default value. Note that you don't have to put a default value. If you don't have that, then what happens is it'll look like this. When it comes up, it won't have a value. And in the danger of that, of course, is that if someone using your widget doesn't set anything, then you will, of course, get an error. So probably best to set default values whenever you can. And in order to make this move, all we're going to do is we're going to take that transform component, which is really, just think of it as another property of the objects. So all of these components that we have here really are things that are properties of this cube, and you can access them. So we want to access the transform property of this cube, and if I hit the dot operator, I can see what transform has. And I want to rotate it, and within the rotation we can see that we have several overloads. We can put the Euler angles, we can pick an axis and provide an angle, and we have X, 0, and Z angles, and that's the overload I think we're going to use. We're going to say we're not going to rotate along the X and Z, but we are going to, whatever we have for speed, we're going to rotate at that rate around the Y. So just like we rotated that wall around in a circle, this is going to rotate the cube, and so every time update gets hit, it's going to rotate basically 3 degrees. So I'm going to save that, go back to Unity, and let's run this. Oh, and I have 0 set in my speed here. Let's put it back to the default, try it again. And we can see we now have a cube that's spinning in the scene. Maybe I'll move it over a little closer so we can see it. So there we have movement. If I check. So the next thing we want to do is control our player character. And to do that, I'm going to select the player and add a component, a new script, and I'm going to call this script mouse look. I'll double click on it to open it up. And to do this, I'm going to create a enumeration. And what we're doing is we're using this enumeration to make it easy to select which direction we want and to associate essentially these different values with these numbers. And we're going to default this so that it moves in mouse X and Y. And if we look at this script and we notice that that gives us the ability to pick an axis for this component. So it's a nice technique to use an enumeration for this. That way, whoever's using your script can have an easier time. Otherwise, we'd have 0, 1, and 2, and that wouldn't be obvious. Or we would use strings, and strings are really too long. So an enumeration is a nice way of setting up your selections for your script. And then what we want to do is, based on that, if depending on what selection is made, we will change how the rotations are done. So here we would do horizontal rotation. If it's Y, then we would do vertical rotations. Or we do both. So we can use that enumeration to decide which way we're going to rotate. So the next thing I'm going to set is a float variable for the sensitivity horizontal. And vertical. And using the same rotation we did with the cube, we'll use that sensitivity number as what is how far we rotate. So let's see what this does. And we're spinning and the cube is spinning, everything's spinning. Obviously we want that spin control to be done relative to what our mouse is doing, so we're going to need some mouse input. And we can do that by adding in by using the input class. So the input class will tell us what our keyboard or the mouse is doing, and we're going to use get axes, and we're going to use mouse X. So what we're doing is this get axes function will return the value of our mouse movement in the X direction, and then we'll multiply with the sensitivity in order to get a rotation. And now we can use the mouse to control the rotation of our view. Note, if you hit play and it doesn't happen right away, you may have to click on the game scene if you have something else selected and come back. You may not be able to move it, so just click on the window and then you'll have mouse movement. So we're able to move in the X and the Y position. I mean, in one plane. Obviously, we want to be able to move in another plane. So we can copy this to the vertical. And for the vertical, we are going to want to use mouse Y. And if I look at my scene, if I'm facing this direction and I'd be facing in the Z direction, then I want to rotate around the X. So I'll move it over to that side and see what happens. And I can move up and down, but not left and right. The disadvantage with this approach, of course, is it's kind of disconcerting to be able to just keep tumbling and rotating. And if the user did that and they're facing the opposite direction, they'd be upside down and it would be kind of odd. So we really want to have a different behavior for our vertical rotation. So rather than doing this, we're going to do a few other things. We're going to define a couple additional variables. A min vert equal to minus 45. A max vert equal to 45. And inside of this script here, and we need a rotation, a variable to hold the rotation we're going to place. And so I'm going to put that in this variable within the update method. And so first we're going to capture a rotation. So we'll start it at 0 and we'll say input dot get access and we're going to clamp this rotation with clamp. You can use it to make sure that a value you put in is no less than or greater than a min and max value. So with our mouse rotation, what we can do is we can use this to take our rotation and clamp it to our min, vert, and max vert values. We're then declaring a variable called rotation y, and we're going to set it to our transform's local Euler angles. So the transform has a rotation value. The local Euler angles will return that rotation in x, y, and z rotations values or angles in degrees. And we just want the one for the y. So looking at our scene, this is the y. vertically that way, and we're just capturing that rotation in our code here. So now we are taking this X rotation, which is clamped in minimum maximum values, and we're applying it we're creating a vector to represent that angle plus the rotation in Y. So we will retain the current facing, and then zero rotation in Z, and apply this, make this be the new rotation. So we're just making a vector say this is where we really want to be pointing at, and then assign it back into the transform's local Euler angles. This will change our player object's transform location to point to the right angle. So now we can see that, oh, looks like my script didn't update. Let's save it and try it again. Now I see it. We have a max min and invert. And something is missing still. And I think the problem is because I put my float variable here on the update cycle, it goes out of scope and it keeps returning it to back to 0 every time this runs. So what I really want to do is place that up here at the class level so it gets instantiated once, and then from then on the value will be retained. That's why you had that weird behavior where it would just kind of skip around. And I don't think my script's updated yet. Let's try it again. And now it's behaving the way I want to. Notice that it stops at 45, it won't go any further, and negative 45 as well. So that's the behavior I want. So the next thing to do is make it so that we can do this in both directions. So I'm going to go back to my code and handle this last use case. And for my vertical, I can do pretty much the same thing, but I also need to get my direction around the x. So for that, I'm just going to say float delta is equal to, we're going to go look at the input, get the rotation around for the mouse's x, multiply by the horizontal sensitivity, so if I think about this, we have the value for the Y rotation, and we have a scalar for the delta for the X rotation. So we'll take the existing Y, and then we'll add the change around the X. So this, if we didn't do this, it would always take the absolute of what the current mouse value is. So every time you stop the mouse, it would point straight forward again. So we need to take the existing Y and then add in the change that's being indicated by the mouse. And here, so now this will just add in the ability to move left and right. So really, X and moving in both directions is the same as moving in Y. Obviously, there's a lot of repetition here. Probably I could refactor this later and eliminate the duplication. And now we have mouse look. I can rotate around. I can look vertical up or down. And so now we have successful mouse look. There's one other thing we need to do. Often when our game may use the character's orientation in order to affect its physics, and we don't want the mouse look to change the rigid body of this player object. So we're going to use get component to access rigid body, and this is a common pattern. You use the get component method, and it's a generic, so we apply the type that we want to get, and that will get us that component. So this is how, so rigid body will point to the physics which is embedded in the character controller. And if body does not equal null, and we'll freeze its rotation. And we'll freeze its rotation. So if we add a rigid body later on to this player, this will make sure that our rotation will only be affected by the mouse look script and not by things that are happening with the physics applied to this object. I'm going to save and test it one more time. And we have a working mouse look script. So let's take a look at our cube, and now we want to work on movement. So if I go back to my spin script, we were working with the rotation, but I could also change the translate instead of the rotate. So if I switch out translate for rotate, let's see what happens. Our cube disappeared, probably moving too fast. And there we saw it go. So let me change this to 0.1. And we can see we have a cube that's floating up into space. So translate will change its direction, whereas rotate changes its rotation. We can use that to change its movement. The problem is that if we that this moves really too fast. And what if we have different computers with different frame rates? What will happen is that cube would move at different speeds on different computers depending on how fast they are. The way we can fix that is by making it frame rate independent. And to make something frame rate independent, all you do is you multiply it by time dot delta time. And that the delta time is the time between the frames. So this will have the effect of removing any differences in frame rates or execution speed. And we can see here it's moving slowly because now it's basically adjusting automatically for the frame rate. So whenever you're doing translations, you almost always want to multiply by time dot delta time. And for fun, we could have both happening at the same time. And now we have it lifting and rotating at the same time. So if we go to our player, we could just keep adding to this existing script, but it's often useful to have each script do one and only one thing. So we're going to make another script called FPS controller, which will handle our movement. And we're going to need to do a few things. We're going to need something to hold access to our character controller. We're going to want a variable which we can use to adjust the speed. And another one for gravity later on. And so when we start off, we're going to use our getComponent method again to get the character controller from our components. So that's going to get this character controller right here. Which means that we can affect any of the properties in that character controller. And we're going to want to first get our get what the control settings are, and we're going to use our get axes control again. If we say horizontal, that will refer to the WASD keys. The reason why we use horizontal rather than just getting the key directly is those are reconfigurable by the player in Unity. So by getting that axis, we can get whatever that axis is associated with and decouple that key directly from, not have to access that key directly, but use whatever the player chooses to use for their horizontal and vertical axis. So we have the keys from the user, and we're going to use the translate function like we did with the cube, and use its delta x, which is what that key change was, and of course we're going to multiply by time.delta time, and same thing with the z. We're going to translate in z, multiply by time.delta time in order to correct for frame rate, and that should give us a movement capability. And we can effectively now move around our scene. We move left and right, we can move forward and backwards, and we can rotate. Let's see if we can go through walls. Yep. So we don't really want to be able to move through walls. And in order to fix that, we're going to capture where our desired movement here. So this vector is going to define the direction we're wanting to go. Delta x, comma 0, comma delta z. And then we're going to also use the clamp function again, because we want the absolute movement to be the speed, and if you move in a diagonal direction, if you just look at the geometry, it could potentially move more. So by doing a clamp magnitude on a movement relative to speed, that will make sure that we won't move, that we'll adjust for angular movement so that they only ever move at speed. And we're also going to set our movement relative to gravity. So this will always pull down on our object so that it stays connected to the ground. Actually, we'll do that later. For now, really all we want to do is we've clamped the magnitude. We'll set the movement and we'll multiply the whole movement by time.delta time. If you multiply a vector by a scalar, it will change its magnitude by that scalar. And then we're going to use the transform direction to change its movement. once we do all those calculations, we can use the character controller's move command to do this movement. And one more note on this transform direction. This vector we defined needs to be defined in global space, but it starts out here in local space. So this transform direction basically takes a vector which is local to the player and translates it to whatever direction the player's facing, so that the resulting vector is global. Otherwise, we would be moving in the wrong direction. And we'll get rid of our old line of code. So now we've changed, rather than using translate directly, we're going to use the character controller's move command. And let's see how that behaves. So we're able to move around, but also we're able to fly. Unless that's a feature you want in your game, we probably don't want that behavior. Notice though that with the move command, it automatically takes care of collisions. So we can't move through walls, but we can fly. So we need to fix that aspect of flying. And to fix that, what we will do is the following. We will set into our movement a gravity component. Basically what we're doing is we're saying every time you move, also move relative, make your movement relative to gravity. So in this case, we're moving minus 9.8 units down, and this will have us falling if we aren't in contact with something. Since we have a floor, that will prevent us from contacting. That will prevent us from floating down. And let's see how that behaves now. So now we're able to move around. If I look up, I can't fly anymore because that minus Y is pushing me down against the floor effectively. And now we have really our first-person controller built, and we can move around the room. If we had an edge which we could fall off of, for example, if I move this, I'm going to make a hole. I back out of it, we would start falling. So that's what minus 9.8 does. And that concludes making our first-person controller. We made mouse-wheel controls, we made a first-person control, and we set it in a scene we created. Thank you very much.